So far we discussed question related to dice and coins. Now let's discuss some different questions, miscellaneous one. There will be many. Let's start. What is the probability that non-leap year has 53 Mondays? Okay, so there's nothing given like total number of outcomes and we need to think something new over here. So basically we are talking over here non-leap year. Okay, non-leap year. Okay. Now leap year means we know that particular year, if we divide with the 4, we get remainder 0. That's a leap year, right? And generally when we talk about non-leap year, how many weeks do we have? We have 52 weeks, right, in a calendar. So let's write number of weeks is equal to 52. Now it means, what do we want to find? We want to find 53 Mondays, right? It's not possible that you will have 53rd or 7 days extra in the year. That's not possible. Okay, but what we want to find, that number of Mondays is equal to this 52 weeks are there, means there will be 52 Mondays. Okay, 52 Mondays plus 1 extra Monday we want to get it, right? Okay, this is what the basic idea is. This is what we want to get, 52 plus 1, right? Now let's understand. So when we have 52 weeks, right, 52 weekdays we can say as well, weekdays, and we want to, there are already 52 Mondays we discussed and we want 1 extra. So how to proceed over here, that 1 extra day could be Monday, could be Tuesday, then Wednesday or Thursday, Friday, Saturday or Sunday. It could be any of it, right? But what do we want as an outcome, right? We want Monday as an outcome. So you can see how many total outcomes are there. 1, 2, 3, 4, 5, 6, 7. Okay, so probability of an event, let's write E. Okay, so how many total outcomes are there? 7, right? That 1 extra day could be any one of it, either Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, any one of it. But we are interested to have that 1 day should be Monday only, right? So total number of outcomes 7, and what we want is Monday only. So Monday is coming how many times? Only 1 time. So probability of getting 53 Mondays in a non-leap year is what? 1 by 7. Similarly, you can do for the Sunday as well, right? Suppose instead of Monday, if it is written Sunday, the answer will remain same, because in a week, in a 7-day week, all these days are coming only 1 time, right? So instead of Monday, it can be changed to any other day, Wednesday, Thursday, Friday, Saturday, but the answer is going to remain same. Paper setters can change the days, right? It depends, but answer is going to remain same. So this is how we find the probability of number of Mondays or any other day in the non-leap year with the 53 Mondays or any day of the week. Let's do one more interesting question. Let's start with the question. A number is chosen at random from the numbers -3, -2, -1, 0, 1, 2, 3. Okay. What will be the probability that the square of the number is less than or equal to 1? Okay, hold on. First of all, let's write the numbers which are given over here. That is -3, -2, -1, 0, 1, 2 and 3. These are the numbers. Now, we want to get that square. If we choose any number randomly, the square should be lesser or equal to 1, right? So let's write, we want to get that square should be lesser or equal to 1 is equal to question mark, right? Now see, this is very logical over here. If they are asking the probability of this square, then we need to do square of all these numbers, That's very logical, right? If you don't do the square, how will you come to know about that which of them are less than or equal to 1, right? Simple logic. So let's do square of them. So minus 3 square, minus 2 square, minus 1 square, then 0 square, 1 square, 2 square and 3 square. Very simple, right? So square of minus 3 is 9, minus 2 is 4, minus 1 is 1, of 0, 0, 1's 1, 2's 4 and 3's 9. Simple. Now let's come into the picture. Favorable outcomes, right? Interesting. We want to get square lesser or equal to 1. 1 होना चाहिए या उससे कम होना चाहिए. Now 9, 4, 9, 4 we cannot take it. But see this one, 0 and this one. So how many favorable outcomes are there? 3. Simple logic. So let's write favorable outcomes is equal to 3. We have 3 favorable outcomes. Simple logic. See, I didn't do much. I just did the square, right? You do the square, apply the condition, less than or equal to 1. 1 होना चाहिए या फिर उससे कम होना चाहिए. तो वो है 1, 0, 1. 3 outcome. 4 and 9 cannot be accepted. Simple. So let's get the probability of square lesser or equal to 1. Favorable outcomes are 3 and total outcomes. Yes, sorry, we forgot that at the start of it. Okay, how many numbers are there? 1, 2, 3, 4, 5, 6, 7. Same you can do over here as well, right? 1, 2, 3, 4, 5, 6, 7, right? So 3 by 7. Very simple. It was given that square, so I did the square. Then you select your favorable outcomes and you find the probability. Similar you can do for the cube as well. If you want to try on your own, that if you take the, like we have the square over here, what will be the probability that cube of this number will be lesser or equal to 1? In that case, there will be many outcomes, right? 1, 2, 3, 4, 5, right? You can try on your own. Instead of square, just write the cube and solve it. Let's move to the next question. Let's do one interesting question with the digits. Let's start with the question. 3-digit numbers are made using digits 4, 5, 9 without repetition. Okay, so we are supposed to make 3-digit number. 3-digit number which has 3 digits, right? Obviously, it could be anything. But there is a limitation that you need to take only 4, 5 and 9. And one more condition is given over here, that you are not supposed to repeat. Not supposed to repeat means what? You cannot take 4 if you take 4 first time, don't take it one more time, right? If you take 4, you cannot take another time. You need to take other 2 numbers only, right? So that is the meaning of without repetition. Done? So let's proceed further. If a number, okay, among them is selected random, what is the probability that the number will be multiple of 5, multiple of 9, will end with 9? No worries. So first of all, you must be thinking that how to get the total number of outcomes and favorable outcomes. We have the conditions. Yes, we do have the conditions, like we need to get the multiple of 5, multiple of 9 and will end with 9. These 3 conditions we need to follow, but at least we should have a sample space with us to select something from that, right? So first we need to create the sample space. How shall we do that? Okay, so it's given that we need to make 3-digit number, right? So I will be starting, just pay attention over here, right? 3-digit. First I will be taking 4. Okay, so 4, if I take 4, I need to take other 2 numbers only, that is 5 and 9. Okay, now what is the another possibility? If I keep the 4 at the first place only, I can interchange them, right? 4, 9 and 5. Done. Now on the first place I am going to take 5 now. Okay, so 5 here. So what are the other 2 numbers I need to take? Let me take 4 first. So what's left? 9. Okay, one more possibility here, that keep the 5 here and interchange 9 and 4. So 5, 9 and 4. Simple. Let's do same with the 9. 9 at the first place. Then what two numbers are left? 4 and 5. Again 9 at the first place and interchange the last two digits. That is 9, 5 and 4. Simple. This is our sample space. There are 6 total outcomes are possible. Now we can go with these conditions, right? So let's try total number of outcomes. Total outcomes is equal to 6. Done. Now we can start our question. So let's follow with the first condition, that multiple of 5. First we need to get multiple of 5 is equal to question mark. Let's start with the favorable outcome. Now multiple of 5 means what? That number, if we divide with 5, will get remainder 0. Now in what case is it possible? If you know the divisibility test of 5, then this sum will be more easier for you, right? Divisibility test of 5 says that if the unit digit means the last digit, right, in a number, either 0 or 5, then that number is divisible by 5. Okay, right? So how many numbers are there? Okay, this is the first number, right? No, this is the second number. So there are two numbers with the unit digit 5. 0 is not possible because we have only 3 numbers. 0 is none of it, right? So there are 2 favorable outcomes. So let's get the probability. Probability of multiple of 5 is equal to favorable outcomes 2. Okay, total outcomes 6. So the final answer is 1 by 3. You can cancel 1s and 3s. Always do that. Done. Now multiple of 9. How do we know that it is multiple of 9 or not? Multiple of 9. Now here we need to take the divisibility test of 9. Now divisibility test of 9 says that if you add all the numbers in the digit, number should be present in the table of 9. Let's talk about this first number only. Okay, 4, 5 and 9. So 4 plus 5, 9. 9 plus 9, 18. Now 18 is the number we are interested in. Is 18 present in the table of 9? Then this number will be divisible. Yes, so 18 is present. This number is divisible. Now rather than checking for all of them, use the logic over here. If you add this 3 number, you are getting 18, right? And in this all 6 numbers, what we are doing, we are just interchanging their places. We are not changing the digits. So all of them, if we add their digits, we are going to get 18. So all of them will be divisible by 9. If you want to check for each of them, you can do addition. 5 plus 4 plus 9, 9 plus 4 plus 5. It is going to come 18 only, right? So let's write favorable outcome. Favorable outcomes is equal to, how many it will be? How many numbers? 6. So 6 will be there. And let's get the probability. Multiple of 9. That is, favorable outcomes are 6 and total number of outcomes are also 6. So this is what kind of event? This is sure event, right? This is 100% going to happen. No doubt in it, right? Okay, let's move with the last one. Will end with 9. Okay, so that number should end with 9. So probability of number end with 9. I think this is very simple. Means unit digit should be 9. So how many numbers are there? Okay, this is the 1, this is the second. Is there anyone? Okay, that's the 2 numbers are there, right? So we can write favorable outcomes is equal to 2. Favorable outcomes is equal to 2, and probability of number end with 9 is equal to favorable outcomes 2 and total number of outcomes are 6. So here same, 1 upon 3. Here 1s are, here 3s are. Very simple. So this was quite unique sum, we need to create the numbers based on the digits given over here. Then we need to find total number of outcomes. Then we need to follow the conditions. Even in conditions, you need to have a knowledge of divisibility test of 5 and divisibility test of 9. That is easy to do, right? Though you can get the answer without it, but that helps you to get the answer quickly and saves your time in exam, right? Let's move to the next question.